So, hi all. In the previous class, we have seen that counting semaphores. As per we told that semaphores are of two types. So, one type semaphores of two types. One is counting semaphore or CS. Another is binary semaphore or BS. People also say it as mutexes. Okay, I'm writing what is the spelling of mutex. One is counting semaphore, which was done, and second one is binary semaphore. Okay, which is also known as mutexes. Okay, so first of all, we have to know why we need to learn mutexes property. This is the most important thing. Okay, so you can see that here s dot value equals to value minus 1, and we can give the value what we want. That means that if you want the value as, let's say, 3, then you can give the value as 3. Now my question is, why we need this value, or what is the objective of using this value? And the answer is that the objective of using this value, it means that at most 3 process can come into critical section. Okay, if I give the value as 3, that means that at most 3 process can come at most in the critical section. As you know that for a synchronizing mechanism, there are 4 properties. Okay, first one of them is mutually exclusive. Mutually exclusive. Second one is progress. And these two are primary properties, and we have 2 other secondary properties. First of all, them is bounded, you must say that bounded waiting. Okay, bounded waiting, WAIT. These two are primary properties, and this is the secondary property, and one of the another secondary property is there, but we have to bother about only primary properties, not the secondary properties. Okay, and so secondary property is architectural independency. Okay, these two are primary properties, and these two are secondary properties. We have to note that we should get the primary properties. Okay, fine. So in our previous case, that is counting semaphore case, you can see that at a time in our critical section, we have at most 3 process. So that means mutually exclusive, this property is completely lost. Progress is well justified, bounded waiting is justified. No, let me know that what is bounded waiting. Okay, so bounded waiting means that the waiting time is bounded. That means that you know that after a certain time interval, the process is bounded or the process is completed. Okay, and architectural independency means your process, or sorry, your synchronizing mechanism will work in any architecture. That means that it doesn't depends upon my computer and your computers. Okay, so this is have done, but our main problem is that mutually exclusive property is lost in counting semaphores. For these purposes, we have designed a new system which is known as binary semaphores. Okay, so to go binary semaphores, we have to know that what is binary. Binary means 0 or 1. All of us know that binary means 0 or 1. So according to the process, we have also here structure BS. In that structure we have two numbers only, 0 or 1. So for this we will use enum value is basic programming or nothing that, and we have also q list l. Okay, after that we have to design the down part. Just I am copy pasting from here. Okay, but these parts will be have been changed. Just see what we have to do. So this is the my down part. So let's check how we can make it. So what is the purpose of using down part? In the above case, the value will be decremented. Okay, but in case of binary semaphores, the using of down is not like that, because we have only two values, 0 and 1. So suppose when a process should have to go into critical section, that is CS, then the process have to cross the first of all the P part, that means the down part, and after that it will have to go the up part, that is B part. So at P part, what we have to, that after crossing a P part, we can see that there is no process can enter into critical section. I'm saying again that suppose a process came into P, fine. After crossing P, it will go into CS, and we are using binary semaphores for exactly using the mutually exclusive property, right? So that means that after coming a process, no other process should have to come. Yeah, so therefore the value, if the my initial value is s equals to 1, then it should be s equals to 0. Okay, if my initial value is s equals to 1, after crossing this part, the value should have to be s equals to 0. Fine. Okay, so I am writing that case. Check if s dot value is equal 1, then what we have to do, just change the value, s dot value equals to 0. Fine. So another else, that means that the value of s is now 0. Why the value is now 0? Because we have said that our enum values is only for 0 and 1. Other than these two value, you will get an error. Okay, so if our value is other than 1, that means if our value is 0, then what we have to do, we just halt, isn't it? We have to halt the process at this step, because mutually exclusive is strictly justified here. So you have to hold the process at this position. So therefore the value at this position should be 0. Okay, so else what you have to do, we just halt that and put the process to the list. After that what we have to do, sorry, after that what we have to do, we have to slip the, I think this part has ends. Now come into up part. Okay, up or V or signal. Designing this part, just check it very carefully that. Fine. So for up part, as per our previous drawing, that is P of S, after that PS and after that v of s. Okay, so after coming a process in CS, it means that the value of s dot value is 0, isn't it? Are you getting? After coming at this position, that means that s dot value equals to 0. Already it has done. So what we have to do for using the value in next case, we have to change it. Are you getting? I am trying to say that after coming this part, we have done with this part. Okay, so now s dot value is in 0. Okay, so at this part we are designing. So in this position, what we have to do, we have to make the s previous above. Previous in the sense after coming the process into ps, how looks like s. Okay, so we have to make the s as 1. That means come. Okay, so I am saying again, look very carefully, that if s dot l is empty, what you have to do right now, I have to make my s dot value equals to 1. Fine. And if it is not empty, then what you have to do else? If it is not empty, then select a process, select a process from list L, and then wake up. Okay, so these is the main thing of up, and this is the main thing of down using binary, semaphore, or mutexes. So I think you are getting that point. Okay, I am just again saying that at this part, above this part, what is happened, the value of s is 0. Now this structure will have to work for each and every process. Okay, I am writing the structure again, isn't it? Suppose this is my ps and this is my cs and this is my vs. So we have to until this part the value of s is 1 at this part. Okay, just before this part, when the process reached at here or it crossed ps, then the value of s becomes 0. This structure will have to work for every process. So after going or exit point, that means that this part, the value of s becomes, what I have to do, from 0 it should make as 1. So this is the whole structure works. So this is the code for that part. Okay, so I think you got the point. If you have any problem or query, just comment me. Okay, fine.